Okay, physics students, I'm going to go through the algebra quiz here. And once again, I asked you to do the best that you could. I would say please go through your answers and compare to what I have here. And let's get going. Number one, use the following equation to algebraically solve for A. So again, anytime we see those words solve for, it means get it by itself on one side of the equation. So here we have f equals ma. I want a all by itself, so I have to get rid of that m. Because m is being multiplied by a, I want to do the opposite to get rid of it. So it's being multiplied right now, so now let's divide both sides by m. Remember that if I do something to one side, I have to do it to the other side to ensure that that's still equal. If I have m over m, those m's cancel out, and what I'm left with is a equals f over m. All right, moving on. Number two, use the following equation to solve for v. So here we have a bunch of letters that maybe you're not familiar with. F, I'll tell you right now, is force, m is mass, v is velocity, r is the radius or the distance. Okay, so if I want to solve for v, again, I want to get that by itself. So I'm multiplying by m right now, so I have to do the opposite. Divide by m. And again, do it to both sides. M over m gets rid of m on this side. All right, now I'm dividing by r. So again, I want to do the opposite. Multiply both sides by r. I was dividing, now I'm multiplying because that's the opposite of dividing. All right, let's rewrite this just so that we can see what we have. FR over m equals v squared. Now I'm trying to solve for v, not v squared. So how do I get rid of the squared sign? I do the opposite. I take the square root of that. And so I have to, again, do it to both sides. And so if we use that function, the square root of FR over m is just the square root of FR over m. And the square root of v squared is just v. The square root undoes the square sign. All right, that's number two. Number three, use the following equation to solve for r. So it's the same equation, but now we're going to do some other things. I want r to be all by itself. And right now, it looks kind of like it's all by itself, but it's in the denominator of that problem, or expression, I should say. So I'm going to multiply both sides by r. And what that's going to do is it's going to get rid of r on one side, but it's going to move it over to the other side, but in the numerator of the other side. Again, this is like rf over 1. We just never write the 1 because there's no point to it. All right, so let's rewrite this. I've got rf equals mv squared. All right, now I want to get rid of f. Right now f is being multiplied by r, so let's do the opposite. Divide both sides by f. And f over f equals 1. So I get r equals mv squared over f. That's my final answer for number 3. All right, moving on. Number 4, use the following equation to solve for k. This is the equation for solving for the period of a mass on a spring. K is our spring constant, m is mass, pi t is period, or the amount of time that is being used for a mass to go up and down. Anyway, that's neither here nor there. Let's just do the math. All right, well, k is inside a square root sign right now, so we have to get rid of that. And the way we get rid of square root signs is we square them. But if we square that, we have to square everything. So this entire expression will be squared, and this will be squared. All right, so let's just move it over here. So t squared is just going to be t squared. 2 squared is going to be 4. Pi squared is going to be pi squared. And the square root of m over k is just going to become m over k. Right? Now, again, I want k to be up on top, And I'm going to do the same thing I did in the previous problem here when I wanted r to move to the top. I'm going to multiply both sides by k. So multiply k here and k here. And here I've got k over k, so that will cancel out. Now I've got kt squared equals 4 pi squared m. All right, again, let's get rid of that t squared. It's being multiplied, so do the opposite. That goes over t squared. And just to rewrite this in a cleaner way, we get k equals 4 pi squared m over t squared. Some of you might have had k equals 2 pi in parentheses squared times m over t squared. Means the same thing, just a different way of writing it. All right, number 5, use the following equation to solve for theta. This is the Greek letter theta. It's a common notation we use for describing what angles we have. All right, so I have sine of theta, so sine of some angle equals x over y. All right, well, I want to get theta all by itself, and I'm taking the sine of it right now. So what do I do to get rid of sine? I take the inverse sine, or arc sine, as some of you may know. Now, if I do the inverse sine of one side, I have to do the inverse sine of the other side. Kind of squished that in there. Well, the inverse sine of sine cancels out sine, and so what I have is theta. And the inverse sine of x over y is just going to be the inverse sine of x over y. I can't simplify that anymore. So that's the answer to number 5. All right, let's move on. All right, number 6. Here we've got some fractions that we're going to be adding together. It says in the following equation, p equals 10, f equals 5. What does q equal? This is something we see a lot during trimester 3. So basically, what I'm going to do is I'm going to rearrange everything first. I want to get q by itself on one side of the equation. After I have that, I will then input those other numbers. All right, so how do I do that? Well, first of all, I need to get this 1 over p. I need to get that over to the other side of the equation. So how do I do that? Well, I'm going to subtract 1 over p from both sides. All right, so 1 over p minus 1 over p on this side gets rid of that. And so now I have 1 over q equals 1 over f minus 1 over p. So how do I now flip everything over? Well, what I want to do now is all right, at this point, I could do some math and get q by itself up on top with one side of the equation. That's going to be a little more complicated without putting the numbers in. So I'm going to start out by just putting in the numbers that I know. So let's take a look here. This is going to be 1 over q equals 1 over f, which is 5, and that is minus 1 over 10. Right. Now, if you're going to subtract two fractions, they have to have a common denominator. So what is 1/5? 1/5 is the same as 2/10. All right, and 2/10 minus 1/10 is equal to 1/10. All right, so what does 1/10 equal? Well, it equals 1 over q. All right, let's write that. 1 over q equals 1 over 10. I can take both of these and just flip them over, or I can cross multiply. That's another way of doing it. Point being, I get q equals 10. And that's the final answer here. Now, on your calculator, what I would do, instead of trying to find common denominators and that kind of thing, what I would do is I would type in 5, and then I would hit this button that you probably have on your calculator. It's called the x to the minus 1 button. And that turns it into 1 over 5. Some calculators you have to kind of do a reverse order here. You hit x to the minus 1, and then you hit that number, and then you hit equal. But regardless, the point is that it's much easier to do it this way, and we'll see that as we get to problems that are like that. All right, number 7, in the following equation, if r1 equals 5 and r2 equals 10, what does r equal? So again, it's kind of doing the same thing that we did before. 1 over r equals 1 over 5 plus 1 over 10. All right, well, we have to get that common denominator again, so 1 over 5 is 2/10 plus 1/10 equals 3/10. All right, again, that equals 1 over r. So if we go 1 over r equals 3 over 10, let's just flip both of them upside down. So now I have r over 1 equals 10 over 3. And basically, again, what does that mean? That means that r equals 3.3 repeating. All right, number 8. This is sort of a two-part problem. F sub x equals mg sine theta, and f sub n equals mg cosine theta. All right, so these are two givens. So then it says, use the above equations to solve for a in the following equation. F sub x minus mu, this is the Greek letter mu. And we use, that stands for the coefficient of friction. F sub n equals ma. So first thing I'm going to do here is I'm going to get rid of m, because I want a by itself. Now, if I divide this side by m, I have to divide this side by m as well. All right, so these m's cancel out, but this m does not cancel out, at least not yet. All right, so now we know that, let me rewrite it, a equals f sub x minus mu f sub n all over m. But we know a few other things. We know what f sub x is, so I'm going to take this and I'm going to plug it in where f sub x is. And I know that this is f sub n, and I'm going to plug that in for f sub n. So I'm going to rewrite that. I'm going to expand the equation out. I'm sort of unsimplifying things. And I get mg sine theta minus mu times mg cosine theta. And that, again, is all over m, which before I said does not cancel out when it's written like this. However, if you have an m in every single term on one side of that equation, they do cancel out. So m is gone here, m is gone here, m is gone here. And what does this all equal? It equals a. So I'm going to put a right there. Let's rewrite it so that it looks neat. A equals g sine theta minus mu cosine theta. All right, so now we're going to get to number 9. And I told you that you're probably never going to see anything quite like this. We might have one problem, but this involves using the quadratic formula. The problem here is you can't really get t all by itself because you've got a squared term here and just another term that's separated by plus sign. You can't factor it out because it would still leave a t right there. So we're going to use, like I said, the quadratic formula, which again is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then you look at that and you're like, what does that have to do with this? Because here I see x's, v's, a's, and t's, and here we've got a, b, c's, and x's. All right, well, let's take this equation here and rewrite it in a form that maybe looks a little bit more familiar. The quadratic form, or a quadratic equation looks like this: a squared plus b, ax squared plus bx plus c equals 0, right? And that's, to solve for x, you go this way, right? Well, let me rewrite this one here. Here's t in this case is x in this equation. So this is 1/2 a t squared plus v naught t. And then I'm going to take this delta x and I'm going to move it across the equal sign. Now what happens to something when you move it across the equal sign? It becomes negative. So this is going to become minus delta x, and that all equals 0. All right? So again, if you compared this equation and this equation, 1/2 a here is the same as just a up here. All right, v naught here is the same as b up here. And negative delta x is the same as c up here. Okay, so I'll just write that as a, b, and c. Okay, so now I can take this equation here and plug some things in. So what is negative b? Negative b would be negative v naught. So I go equals, equals negative v naught plus or minus the square root of v naught squared, because that's b squared, right here, minus 4 times a, which is 1/2 a, times c. c is negative delta x. All right, and that's all over 2a. And a, again, is 1/2 a right here. All right. From here, again, we're not going to put any numbers in, but we can simplify some things. So again, negative v naught stays the same, nothing changes there. Plus or minus, I take the square root, v naught squared. And all right, so here I've got 4 times 1/2, so that's going to be 2. This is a negative sign, this is a negative sign. When I multiply them together, they're going to become positive. So this becomes plus 2a delta x. And this is all over 2 times 1/2, which is just 1. And so all I'm left with there is a. So the answer to the bonus was this. Like I said, probably not going to have to do that one. I know that you have your quadratic formula in your calculator though too, so that would be a possibility. All right, talk to you later.